So, hello, good evening. Welcome to the fourth problem solving session for the whole environmental remediation of contaminated sites. So, like always, like for the last 3 weeks, what we are doing is like we are going to a brief recap of the lecture part, and then we are trying to solve the previous year assignment question. So, first, let me share my screen from the lecture. So the first lecture was about basic introduction about the hazardous waste, what are the various rules, and then the first and second half part of the first and the full second lecture was about the characterization for the carcinogenic compounds and to find out the hazard quotient, the hazard index for the non-carcinogenic compound. And then in week third, we have seen lecture material on the treatment of groundwater and based on pump and treat method. So there we have seen that we can pump the entire groundwater and treat it, and either we can recharge it again or we can use it for some other purposes. And then in pump and treat, we have seen that when the contaminant is only in the aqueous phase, then that process is feasible. And when the contaminant is in the adsorb phase, then the time required for remediation is very long because the contaminant partitions between the solid phase and the liquid phase, or it is not partitioned. Basically the contaminant is getting absorbed on the sorbed on the solid sediments or soil in the aquifer, and it is uh, getting dissolved in the aqueous phase when the concentration is getting reduced. And also we have seen that when there is some NaPl, that is the non-aqueous phase liquid, then also the retardation factor is very high at the remediation time for the pump and treat method in years. Sometimes it is coming out to be hundreds of years. So pump and treat method is not feasible where there are where the pollutant is distributed in different phase, like it is either soft and dissolved, or either it is in some NaPl phase. It is associated with some NaPl phase, or it can be dissolved, or it can be on the sediment. Or also the pollutant can be some NaPl, like it can be a low density aqueous phase liquid, or it can be a high density aqueous phase liquid, where on the low density it will float at the surface of the water, and in the case of high density, it will move through the water and it will get settled at the bottom of the non-porous layer. And slowly, with time, when the concentration of the pollutant will decrease with pumping the groundwater, then this pollutant will again dissolve in the liquid aqueous phase and try to achieve equilibrium. And that's why we say we see tailing and rebound in case of pollutants which are present in different phases in the aquifer. So the next treatment method which we are discussing is the permeable reactive barriers. So PRBs are the treatment method in which we provide some reactive layer or reactive barrier in the aquifers where the groundwater flows, and in these layers there are some compounds like zero valent iron, where uh, they act as some electron donors and reduction of the contaminants take place. So we will see about CRV. So as I have told you, if my screen is visible, let me okay, my screen is so as I have told, the PRB can be installed in the equipment where there can be some material or compounds in the barrier layer where the pollutant is getting removed and the clean water goes further. So there are different types of PRB. So basically, this is the configuration of the PRB. So it can be continuous PRB or it can be funnel and gate PRB. So in the continuous PRB, the reactive layer is such that it is in the whole width of the groundwater flow, so that we are not restricting the groundwater flow. But in funnel and gate PRB, funnel and gates are provided to direct the groundwater flow towards the PRB, and like this, the groundwater is treated. Next, in funnel and gate PRV, there can be a single gate like here, or there can be multiple gates. Like there are two gates for directing the waters to the PRV. Next, so this is the figures for installation of PRV in a contaminated site in units. So PRV can be applied in areas where there are unclear location of sources. So we do not know what source is causing the pollution. So in that case, we cannot identify the source. So pump and treat will be very difficult and time consuming, because as soon as you pump the groundwater and treat it, then again the contaminant concentration will increase. So in these cases, PRV can be used, and also where there is no contaminant released from the sources. So where there is no tabling and rebound, we can use the PRV. Where there is low solubility of contaminants, so when there will be low solubility, there also we can see tabling and rebound. And then we have to treat large volume of contaminated soil. There we cannot apply pump and treat, but we can apply PRV for the treatment. And also in CRV, there is no construction on the ground. So uh, that's why this is also one of the advantages. So now let's discuss about the treatment. So here the treatment affecting the surface, subsurface. There is no built-up area on the ground surface. So this is one of the very good advantage. And there is no requirement of any ground structures, or there is no very less or no requirement of labors for day-to-day monitoring or other activities. And it allows full economic use of a property. So PRVs are installed into the in the subsurface or in the aquifers. So the ground or the soil ground above that aquifer is free from any construction effort, and it can be useful. And here the treatment is basically passive, like we are doing the on-site treatment. In situ treatment. And here the operation cost is low, and also the maintenance cost is low, because these values can last for years. So for the removal of the pollutant, and here the monitoring can be focused. Let's look at the next. So there can be different mechanisms through which the pollutant is treated. It can be based on oxidation and reduction reactions. So we have seen an example of the T3, that is triglycerol, where the uh, uh, ethylene trichloroethylene was reduced. It was reduced uh, it was reduced to, I think, ethane or ethene, and it can be a acid-base reaction where pH can be controlled. So suppose if some heavy metal is in the aquifer, and generally these heavy metals would precipitate in the pH of greater than 8. So if we can increase the pH of the water, then the precipitation of the heavy metals can be achieved. Then there can be chemical precipitation, like that I said. There can be sorption reactions. So what will happen? I say there can be some compound which solve the pollutants on its surface, and like this, it can be removed from the state. Also, we can use biological degradation reactions, like we can use the microbes to enhance the removal. So there we can be some microorganisms on the here, and these microorganisms can degrade the pollutants. So these are the used for contamination of water with chemicals and petroleum products. So here example for oxidation reduction is given. So here we can see that this is a zero valent ion. So it is getting electrons. So it is getting oxidized, and this to HCl3, this is a reduction reaction. So here it is getting formed to HCl. So there can be different mechanisms also. Again, an example is given for chromium. So due to the hexavalent chromium, so it is the carcinogenic. So when it is taking the electron, the region reduced, then some going to chromium ether, and chromium ether is generally present in the solid form. So it will precipitate out from the surface. So again, okay, an example, again, the example is given for selenium chip. The selenium chip is more surface soluble than selenium ore, and also the treatment can be applied for uranium chip by elemental iron, where the just uranium, sorry, uranium is reduced, but by reductive precipitation, it can be solved on the hydrophilic oxides, or it can co-precipitate with iron. So, so the So the mechanism for the removal of pollution methods from the water using zero valent iron is here. It can be absorption, like the pollution getting absorbed, absorbed in the surface of the bulk of the uh, uh, zero valent iron, or it can be combination of sorption and reduction, like it is getting soft also, and also some part of the heavy metals are getting reduced because the iron will give the electrons, so reduction reaction can be enhanced. So like this also. And the third mechanism is like there will not be any sorption, there will be reduction. The last side. So this table gives the idea for the selection of reactive media based on the targeted content. So if we have yellow carbon and reducible metal, then we can use zero valent ion, and with technology is interactive. And if we have biological, it's on structure. Sorry, if we have the target contaminant is petroleum hydrocarbons, then we can use biological petroleum structures. And these are the microbes, and in practice, this is that this technology is also being implemented over. So the suitability of a particular contaminated site for PRP is affected by following factors. So first is the contaminated site. So what is the type of contaminant? And this will affect whether the PRP will be suitable for treatment or not. Then next is the field size and distribution and dimensions. So proper knowledge of proper details of the field size and distribution of the aquifers is very, very important, because the sometimes if if there is some rain and the direction of the ground flow changes, and if we have not taken this into account, then the PRA will not be able to remove the content, and we can see some higher concentration of the content in the water, in the pump water. Next is the depth of the ectotower, needs a strong of the flow characteristics. We need to know what the hydraulic conductivity is required. Velocity of flow and other characteristics. Porosity or characteristics. Next is there should be knowledge about groundwater geochemistry and the constructability, like whether GRB can be installed or not. So this is the table which shows us the redox potential, that is pH not higher the pH not value. It means that suppose in this table oxygen is at the top and it has like pH not value of E20. So again there will be free electrons available, and if we have oxygen and nitrite, then oxygen will take the electron and this process will down. So suppose if we have sulfate and CO2, then sulfate has the higher EH naught value, that is minus 220 as compared to minus 240. So sulfate will take electrons and it will get reduced. So the value this scale or the values of EH naught tells us about which is the most reducible species here. So we need to know some of the characteristics of the sites. We need to know what is the composition of the groundwater. Like we need in the composition of the groundwater, we need to know what is the concentration of the contaminants, what are the various types of contaminants, what is the plume distribution, and what is the overall geochemistry of the groundwater, like pH, what is DO, what is the concentration of various ions like calcium, magnesium, sodium, potassium, chloride, etc. Next is we need to know hydrogeology of the affected aquifer, that is the stratigraph. So what are the various layers inside the aquifer and what is the groundwater capacity and nature. And these will help to select the appropriate active media and construct creativity tests and design the teams of the work. So we will be solving questions based on designing on the thickness of the walls. Some data about the volume of the plume distribution and what is the velocity in the aquifers and other parameters will be given, and we have to define the thickness of the permeable with the permeable reactive value. So again here an example was given. So here is the example which shows that if we have not correctly accounted for the behavior of the groundwater flow in the different seasons, like here you can see when there is no rainfall, then this flag is on PRB, so the groundwater flow is in this direction, so the water will pass through PRB and it will get treated. But suppose there is a rainfall and due to that, the flow of the groundwater deviates and it is not passing, and whole of the water is not passing through PRB. So we can see the increase in concentration of the pollutant in the treated water. So proper details of the aquifer is very, very important for the proper care also to treat the water. So again, these are the snapshots for the batch experiments or column test to find out the select what reactive media we can use to use the problem. So repeat. So the removal of contaminants can be due to various mechanisms. So one such is hydrogenology, like the constant will accept electrons, which is basically the reduction reaction, and if you are accepting electrons, and it is getting through the oxidized form. So this oxidized form is uh, less harmful than the previous form. So again, an example is given like here we have nitrates, so this is the most oxidized form of accept electrons and electric reduced to ammonia and green form formate, so it has plus 6 charge, so it can accept electrons that gets reduced to principal and it precipitates after solid. So kinetics also play a part because there is this equilibrium tells thermodynamics tells us about whether a reaction or some system where a reaction is feasible or not, but kinetics that tells us how fast or slow the reaction will proceed. So suppose for a reaction A plus B giving us the product, so we can write the reaction rate for the rate for the reaction as K times concentration or the emotion activity of the activity A into activity of activity B. And if the reaction is such that the concentration of A is getting reduced very slowly or it is in excess, then we can consider it as constant and then we can multiply to get a new rate constant and then reaction so the symbol first of the reaction kinetic. So initially by writing that reaction kinetic, we get the idea that it is a second order reaction. But when we consider the concentration and the activity of those species, then we got that basically it is a single first order reaction. Let's move to the next picture. So this is about mass balance. Mass balance is for sure. So change in so the overall change in mass per kinetic can be written as mass in minus mass out plus minus s. Like there can be some uh, generation of the contaminants or there can be some removal of the contaminants. So plus for formation and minus for loss of the contaminants. So after sorting all the so after solving all these for the blood flow reactors, so the flow in the reactors consider as blood flow process. So we can find out uh, this expression where the but this is a concentration at a time the direct initial concentration is being immediate from here. So from here we can find out theta and theta is nothing but area divided by the charge of the flow and this is volume multiplied by capacity of the PRD here divided by Q will give us the retention time and using this expression we can like first we have find out what will be the retention time and from retention time using this expression we can find out what will be the thickness of the cap. So again, case study is being explained and I think this case study is still left. So please go through the lecture slides to learn about the case study. So basically, this time the lecture is based on the design of the PRG layer, what are the different types of PRG, what are the practical which affect the PRG, what are the application and advantages, and so on. And in design of the PRV, we need to find the thickness of the PRV and also we can find out how much mass of the uh, compound is loaded in the PRV layer. So now let's go directly to the questions. So let me I was uh, I was not able to see that you were reading in the to join. So now let's try to solve the question. So let's go to the first question. So the first question is select the correct statements from the following. First is dark wave velocity will be greater than surface velocity. Option B is seepage velocity will always be greater than downward velocity. C is chromium in first oxidation state is more soluble in groundwater as compared to chromium in plus 3 oxidation state. Option D is while calculating the flow through an aquifer using downward velocity, we need to consider the porosity of the aquifer. Option E is while calculating the flow through an aquifer using seepage velocity, we need to consider the porosity of the aquifer. So we have been given five statements and we have to select the correct statement. So there can be more than one option which is correct. So please try to find out which of the following options are correct and please write that in the chat box. And then we will begin with the question. So let's see which of the following options are correct. So first option is Darcy's velocity will be greater than seepage velocity. No, this statement is not correct because in Darcy's velocity, it is considered that the that velocity of water through a particular cross section of the soil. Porosity is not considered here. Wherein seepage velocity we consider the porosity, and we divide the Darcy's velocity with the porosity to get the seepage velocity, and this value is greater than the Darcy's velocity. Next option is seepage velocity will always be greater than Darcy's velocity. So this statement is correct. So B is correct. So our next statement is chromium 6. Chromium in plus 6 oxidation state is more soluble in groundwater as compared to chromium in plus 3 oxidation state. So we have seen in the lectures that chromium in plus 6 oxidation state is in the form, it's in the soluble form, and by and by reducing chromium 6 from chromium from chromium plus to chromium 3, we can precipitate out the chromium, because chromium 3 is generally formed solid compound which get removed from the aqueous phase. So this statement is also correct. So fourth statement is, while calculating the flow through an aquifer using Darcy's velocity, we need to consider the porosity of the aquifer. No, in Darcy's velocity, we do not consider the porosity of the aquifer. We just consider that for a particular unit of the cell of the soil, without the porosity, we find out the Darcy's velocity. But option E, so D is not correct. So option A is, while calculating the flow through an aquifer using seepage velocity, we need to consider the porosity of the aquifer. So this statement is correct, that we divide the Darcy's velocity with with porosity to find out the seepage velocity. So porosity is considered in calculating the seepage velocity. So this option is also correct. So only A and D was not correct. Rest three statements are correct. So now let's move to the next question. So the question is, select the correct options regarding PRB, that is a permeable reactive barrier. First, PRB is an active technique. Option B is, no above ground structures or no day-to-day labor attention is required. Option C is, potentially lower operation and maintenance cost. And option D is, wider monitoring network is required as compared to pump and treat method. So these four options are given, and as I told you in question 1, so there can be more than one option which is correct. So please write all the options in the chat box, and I'll request you all to please participate in solving these questions. Whatever option you think is correct, please write in the chat box, and then we will discuss the all the options. Because if you are registering for the exam, so similar type of questions will be asked in the final exam. So please write your whatever option you think is right in the chat box, and then we will discuss.
So let's see which of the options are correct. So I got one answer as mm, A, B, and C. No, A, B, and C are not correct options. So B and C are the correct options. So first is PRV is an active technique. No, PRV is not an active technique. It is a passive technique where the PRVs are installed and when the water flows through it, it gets pollutants get removed. Next option is no above ground structure or no day labor attention is required. So this is correct. Like the barriers are installed in the subsurface, so there is no above ground structure and the ground can be used for other purposes. So B is correct. Next is potentially low operational and maintenance costs. So this is correct because these PRVs can last for years and without getting exhausted, or the breakthrough point comes at very in few years. So maintenance and operation cost is also low. And next is wider monitoring network is required as compared to pump and treat. No, wider monitoring network is not required. So in pump and treat, wider monitoring networks are required, but in PRVs, lesser monitoring wells are required. So B and C are the correct option. Now let's move to the next question. So the question is match the following contaminants and the reactive media that can be used in the PRV to remediate the groundwater. So we have to match the most preferred media with the contaminants. So we have seen a table in the lectures where the different reactive media were given for different targeted contaminants. So we have four contaminants. First is the TCE, next is acidified water, third is mixture of oxidized and reduced organic, and fourth is benzene and toluenes. And we have given four reactive media: limestone, sorption reagents, zero valent ion, and fourth one is electron acceptors that promote bacterial activity. So we have to match the targeted contaminants with the most suitable or preferable reactive media. So I'll give you all 3 minutes. Just take your time, write the correct options in the chat box. So basically here only one option will be correct. So please write that correct option which you think is the correct in the chat box and then we will discuss. So let's see which option is correct. So for TC, generally zero valent ion is used. So for TC, it is zero valent ion. For acidified water, so the pH will be less, so we need to increase the pH, and limestone can be used for that. And third is mixture of oxidized and reduced organics. So we can use some sorptive agents for that. To remove the oxidized and reduced organics, they will get sorbed on the these reactive media and can be removed. And last is the benzene and toluene. So we can use some electron acceptors that promote bacterial activity. So option D will be correct. So now let's move to the next question. So the question is, choose the environmental conditions where the implementation of PRB as a remediation technique would not be suitable. So now we have to take consider the environmental conditions where PRB as a remediation technique is not suitable. So first is rapid release of contaminants from the source. Next is unclear location of source. Option C is contaminants which are inert with respect to reduction, oxidation, and or are difficult to precipitate. And last option is large volume of contaminated soil. So again, please write the option in the chat box and then we will see which one is the correct. So let's see which of the following options are correct. So only two options are correct. So I get one answer is A, B, and D. No, only A and C are correct. So B is also not correct answer. So we have to select out of the conditions or sites where PRB is not suitable. So we have seen that when there will be rapid release of contaminants for the source, then PRB is not suitable for that. But when there is slow release of contaminants for the source, then PRB can be installed. So next is unclear location of source. So when there will be unclear location of source, then we can install PRB. So because PRB is a passive process, there will be barriers in the aquifers from, and water will pass through these barriers and it will get treated. So we do not need to know the exact location of the source. So PRBs are suitable for these. So option A is correct. Next option is contaminants which are inert with respect to reduction oxidation and are difficult to precipitate. So these cannot be used for PRB because in PRBs we generally give some adsorbents or some compounds which remove the pollutant either through increase or decrease of pH or through reduction or oxidation or redox reactions or through sorption. So we have seen all these in the mechanisms or processes responsible for removal of pollutant. So this option is, so here since we have given that the contaminant is something which is inert with respect to reduction oxidation reactions, so these cannot be removed with the PRB. So this is not suitable for PRB installation. And next is the large volume of contaminated sites. So these type of site is suitable for PRB for removal of pollutants for PRB. So option A and C are the correct option, that these two situations are such where PRBs are not effective or suitable. Now let's move to the next question. So we have so this question is based on the case study which was discussed in the lecture. So the question is, as per Fry Canyon site at Utah discussed in lecture, select the correct statements from the following. A is the site is contaminated with uranium and continuous type PRB is used for remediation. B is the site is contaminated with chromium. Funnel and gate type PRB is used for remediation. And C is the site is contaminated with uranium. Funnel and gate type PRB is used for remediation. And the last option is the site is contaminated with chromium and continuous type PRB is used for remediation. So we need to remember what was the contaminant through which that particular site was polluted, and we have to remember what was the type of PRB used, whether it was a continuous type PRB or a funnel and gate type PRB. So again, I will give you all 3 minutes. Just take your time and write the option in the chat box, and then we will discuss. So in the site which was in Utah, so that site was contaminated with uranium, and the type of PRB used was funnel and gate type PRB for the remediation. So option C is correct. That the contaminant there is uranium, and funnel and gate type PRB is used for remediation. So now let's move to question 6. So the question is, refer to the conceptual model for metal removal from groundwater using NZVI below. Select the correct option which matches condition A, B, and C. So these are the condition which is given. So A, B, and C. And we have to find out whether it is sorption or sorption and reduction or reduction only. So we can find out based on uh, these E naught values. So based on E naught values, we can find out. So please write the option in the chat box and then we will discuss. So I got to answer as C. So let's see which one is the correct. So first for A, it is given that for metal cations, where E naught is more negative than or close to E naught value for iron, like zinc or cadmium. So when the E naught values of the pollutant will be, or the heavy metal will be similar to E naught value of iron, then if iron is getting oxidized and if it is giving electrons, and the E naught value of suppose zinc is similar to that of iron, then zinc will not accept that electron, rather it has affinity to donate the electron. So we cannot remove zinc and cadmium metals with redox reaction. So here the only mechanism possible can be sorption. So A will be sorption. So next option is for metal cations for E naught slightly more positive than E naught of iron. So suppose for nickel and lead, so we have E naught that is more positive than iron. So we have seen in the table that when E naught value, the compounds which have higher E naught value, they will preferably accept electrons as compared to the compounds which are lower in that table. So if nickel and lead have more positive E naught value, so they will accept the electrons. But here the difference between E naught values is not that much. So there will be obviously reduction, but also we need to remove these metals by sorption also, because the difference in value of E naught of nano zero valent ion and the pollutant is not that much. So reduction reaction will not wholly remove the pollutants. So B will be reduction and sorption. And last is for metal cations with E naught substantially higher than E naught of iron. So if suppose we have we have examples of heavy metals like silver, copper, and mercury. So these have E naught values very higher than iron. So whatever electrons will be given out during oxidation of iron, those electrons will be accepted by these metals, and they will be converted to the reduced form, and they can be removed. So since E naught values of these metals are much higher than E naught value of iron, so there is a large difference between the E naught values, and so these reaction pollutants can be removed by reduction only. So A is the correct option. That A is our sorption, B can be removed by sorption and reduction, and C can be removed by only reduction. Now let's move to the next question. So calculate the oxidation state of chromium in chromate ion. So let me write it correctly. We have CrO4 2 minus. So this is the chromate ion, and we have to find out the oxidation state of chromium. So all of you please try to find out the oxidation state of chromium. So this is very basic question of chemistry of finding the oxidation state of a metal in any compound. So again, I will give you all 3 minutes. Just take your time and write the option which you are getting in the chat box. So let's find out the oxidation state of chromium in chromate. So to find out the oxidation state, we will consider the oxidation state of chromium as X. We have 4 oxygen atoms, so 4, and the oxidation state of oxygen is -2, and it will be equal to the overall charge on the compound. So here it is 2 minus, so it will be minus, yes, -2. So X will be -2 plus 8, so it will give us +6. So the oxidation state of chromium in chromate ion is +6. So A is a correct answer. So this is pretty straightforward. So let's move to the next question. So the question is, as per the complete reaction given below, select the correct options. So we have been given the reduction of trichloroethylene to ethylene or ethene, and iron is oxidized from 0 to +2. So we have to select the correct option. So option A is pH will decrease after the completion of the reaction. B is Fe0 works as an oxidizing agent. C is Fe0 is working as reducing agent. D is Fe0 is oxidized from Fe0 to Fe2 plus. CHCl3 is reduced to C2H4, and pH will increase after the completion of the reaction. So based on the reaction which we have to select the correct statement. So there can be more than one option which will be correct. So please write the correct option in the chat box, and then we will discuss. So let's see which of the following options are correct. So first option is pH will decrease after the completion of the reaction. So from the reaction we can see that H plus is consumed. So if there will H plus will be consumed, then OH minus will be more in the system, and because we know that because of hydroxide ions, pH increases in the system, so pH will increase. So there will be increase in pH. So he is not correct. Next is Fe0 works as an oxidizing agent. So let's see what is happening to Fe0. So Fe0 is going to convert to Fe2 plus and it's giving out 2 electrons. So here we can see that oxidation of the Fe0 is taking place. So since oxidation is taking place, so it will be a reducing agent, not an oxidizing agent. So it is an reducing agent. And this overall reaction is the oxidation reaction. So B is also not correct. C option is zero valent ion is working as a reducing agent. So this statement is correct. Fe0 is acting as a reducing agent. It is itself getting oxidized, and but it is a so it is a reducing agent. It will reduce the other compound. So option D is Fe0 is oxidized from Fe0 to Fe plus 2. So this is also correct. Option E is trichloroethylene is reduced to C2H4. So this is also correct. So what is happening is C2H. So I'm not writing the reactions stoichiometrically. So it will accept electrons and it will convert to ethylene or ethene. So this is the reduction reaction. So this is the reduction reaction. So reduction of, sorry. So reduction of trichloroethylene or TC is taking place. So this is correct that C2HCl3 is getting reduced to C2H4. And the last option that pH will increase after the completion of the reaction. So this is also correct because with consumption of H plus, OH minus will be more and this will increase the pH. So option C, D, E and F, all these four options are correct and A and B are not the correct options as per the reaction given. A, C, D, E. No, C, D, E, and F are the correct options. So now let's move to the next question. So question 9, 10, and 11. So this is not 12, I think. There are only 3 numericals. So there are 3 numericals based on this problem statement. So the problem statement is a plume to be remediated by PRB is 200-meter long, 20-meter wide, and 10-meter deep. Aquifer porosity is 0.35. PRB porosity is 0.04 and K for the reaction rate constant for PRB is given as 0.28 per hours in field and TC maximum concentration is found to be 10 milligram per liter. So we have C naught as 10 milligram per liter and then the target concentration is 2.5 microgram per liter. So C theta is given as 2.5 and concentration of zero valent ion in batch reactor is 125 gram per liter. So question 9 is consider that the system behaves as a pseudo first order system with a rate constant of 0.28 per hour. The retention time required in the PRB for the same influent and remediated water concentration in hours is. So we have to find out the retention time required for this particular system to reduce the concentration of TC from 10 milligram per liter to 2.5 microgram per liter. So based on we have to consider the reaction as a pseudo first order reaction and we have to find out the retention time. So again I will give you all 4 minutes. So take your time and try to write the value which you are getting in the chat box and then we will see how to solve this question. So I request every one of you to please at least try to solve these questions. So let's see how to solve this question. So we have been given the maximum concentration of TCE. So let's first write out whatever is given. TCE maximum concentration is 10 ppm. So we will convert it into microgram. So it will be 10,000 microgram per liter. And the target concentration is, it is 2.5 microgram per liter. And we have to consider the reaction as a pseudo first order system. So for a first order reaction, we use the following equation, that concentration at any time t is given as initial concentration exponential raised to the power of minus k theta, where theta is the retention time. And we have been given reaction rate constant is 0.2 per hour, 0.28 per hour. So we will now put everything in this equation. So CT is,
Excuse me.
yes.
How we know that it's a first order reaction?
So it is given now that consider the system behaves as a pseudo first order reaction system.
Okay, okay, okay.
So we have K as 0.28 and we have to find out the theta. So after simplifying this equation, taking log, natural log on both sides, we can solve it. And we are getting, so on solving this, we will get 29.6. So let's take log on both sides. ln 2.5 minus 0.28 theta. So on solving, we will get theta as 29.62 hours because K was given in hours. So the unit for theta will be R. So we find out the retention time required in the PRB to get the targeted concentration as 29.62. So I hope this question is clear to all of you. So if you have any doubt, then you can unmute yourself anytime and you can ask the question. So let's move to the second part for this question, which is question number 10. So again, the data is common. The question is, if the Darcy's velocity through PRB is 20 meter per year and retention time is 100 hours, then the required thickness of PRB is no, this was centimeters. So we have to find out the thickness of the PRB. So let me give a hint for this question. So we have been given the Darcy's velocity, so we can find out the discharge. What will be the discharge? So velocity for the Darcy's velocity is considered by taking out the cross-sectional area. So here we do not consider the porosity. So Darcy's velocity will be discharge per unit cross-sectional area. And here from here we can find out the discharge. And for the given retention time, there was a uh, final equation which we got out as that retention time is porosity into volume divided by Q. So volume of the reactive barrier. So using this equation, we can find out the thickness of the uh, PRV. So first we have to find out discharge. So Darcy's velocity is given. So it is given as discharge by cross-sectional area. So please now try to solve this question. Like first we'll find out the cross-sectional area using the Darcy's velocity, and then we can find out the thickness using the second equation. So again, I'll give you all 4 minutes to try to solve this question, and please write whatever option you are getting in the chat box, and then we will discuss. So 0.01 watt. So I think it's okay, centimeters. 0.01 centimeters. So 0.01 is not correct. So let's see how to solve this question. So we have been given Darcy's velocity as 20 meter per year, and we have the cross sectional area. A will be the for the plume, it is 20 meter long, 20 meter wide, and 200 meter long. So the cross sectional area will be width into depth, 20 into 10. So it will be 200 meters square. And from this equation, that Darcy's velocity is given as ratio of Q by A. So our discharge will be uh, Darcy's velocity into A. So it is, I guess, 20 into 200, 4,000 meter cube per year. So we need to convert it into meter cube per hour, I guess, because I guess retention time is in hours. So we need to convert it into hours. So it is 0.45. So it will be 4,000 divided by 365 days in a year multiplied by 24 hours in a day. So it is coming out as 0.456 meter cube per hour. So now next, we have to find out the thickness. So retention time is given as porosity into volume of the PRB divided by discharge. So porosity into volume will be given in terms of width into depth into thickness upon Q. So the type of PRB is not given. So if the type of PRB is not given, then we will consider the width and depth as same for that as given for the plume. So thickness will be theta times Q by epsilon into uh, width into depth. I think I am having some issues with the pen. So theta is given as 100 hours, retention time is 100 hours, discharge is 0.456 meter cube per hour. So this is an hour. Divided by porosity is given as 0.35. Width is, I think, 20. Depth is 10. So this is in meter and meter. So we will left with meter. So it's coming out to be 6.65 meter. So we will convert it into centimeter by multiplying by 100. So it will be 65 centimeters. So 65 is the correct answer. The thickness of PRB required is 65. So now let's move to the next question. Just give me a minute. I need to check whether we have to take the porosity of PRB or the aquifer. I think it is porosity of the PRB only. Exactly. So we are finding out the thickness of the PRB. So we have to consider the porosity of the PRB. So PRB porosity is 0.4. So let me correct it. So this is also for PRB because we are finding out the thickness of PRB. So it is 0.4. So our values will change. So we are getting 57, not 65. So to find out the thickness of the PRB, we need to consider the porosity of the PRB because water will pass through the PRB. So porosity of PRB will matters. So porosity of PRB is 0.4. So on solving this, we are getting 57.57 meter, which is coming out to be 57 centimeter. So this is the correct answer. So now let's move to the next question. So the statement has been slightly modified because the question is calculate the mass of iron required for the continuous PRB in kg. So now the uh, um, details for the PRB layer is given that PRB will be designed with a mixture of zero valent iron, which will be 30% by mass, and sand will be 70% by mass. And the porosity, now the porosity of mixture is 0.35 and its bulk density is 2.7 kilogram per liter. So from using this information, we have to find out the mass of iron required for the continuous PRB in kg. So please try to solve this question. So let me give you the formula. So the formula for mass of iron, sorry. First we need to find out the fraction of iron in the mixture. So it will be the fraction of iron. in mixture multiplied by bulk density of the mixture into total volume of the PRB. So I think we have calculated the thickness of the PRB in the previous question, but we have considered in the previous part the porosity of the PRB layer was given as 0.4. So here we can see that the PRB porosity is 0.4. But in the next statement, the porosity of mixture is given as 0.35. So first we need to find out the thickness of the PRB layer using 0.35. And then we can substitute everything in the equation, and then we can find out the uh, mass of the iron required. So let's first find out the thickness of PRB layer. So we have seen that theta was given as Darcy's velocity. So in the previous question, we have find out the discharge. So discharge will not same because I think this Darcy's velocity is same. So now let me write only. Darcy's velocity is 20 meter per year. So using Darcy's velocity as 20 meter per year, we are getting the discharge as 0.456 meter cube per hour. And we have seen that retention time is given as porosity of PRB into V by Q. So thickness will be Q theta into Q by porosity of PRB into width into depth. So retention time was given as I think 100 years. Yes, it was theta was 100 year. So 100 hours it was, not years. So it was 100 hours. So 100 into 100 hours into discharge is 0.456 meter cube per hour divided by, now we will use the porosity of the mixture, which is 0.35. Width we will use as same given in the question, which was 20 meter, and depth is given as 10 meter. So on solving this, I guess we're getting 65. Yes, we are getting 0.651. Let's write 0.65. It is coming up to a 65 centimeter. Now we have to find out the mass of iron required for the continuous PRB. So we can now find out easily. So mass of iron required, it will be the fraction of iron in a mixture is 30%. So 30 by 100, it will be 0.3 into bulk density of the mixture, that is 2.7 kg per liter. So let's convert this into kg per meter cube. So 2700 it will be. So we'll multiply it by 1000 to convert it into kg per meter cube. And we have the total volume of the PRB as total volume will be 20 in 10 into thickness. So it is 20 into 10 is the depth into the thickness of PRB is 65 centimeters, so 0.65. So this overall we will get in meter cube. So meter cube will cancel out and we will get the value in kg. So on solving this, we are getting so it's coming out to be 105300 kg. So this much is the amount of iron required for the PRB. So these were the questions based on previous year assignment questions. So I hope these questions are clear to you. I think there are similar numericals or slight difference in the numericals which are there in the present assignment. So I hope yeah, these numericals will help you to solve the present assignment questions. And if you have any questions, then you can ask, or otherwise, we can end the session here.
Ma'am,
Ma'am,
this
this
on Friday, is it the same class or it's different? Because I try to log on with this Microsoft Teams, it's not working with me. So
not
is it the
work.
same class?
No, the TA is different. So some other TA is taking class on Friday. But I
Okay,
think
okay.
he will be solving the solving similar questions only.
Okay.
So what
So
problem you
you
are?
are taking on.
Yeah, mine is on Sunday from 6 to 8 p.m.
Okay, okay. So that video is not uploaded
Okay, it is not
in the
uploaded.
problems. No, I could see only yours. The other one I did not see in the problem solving session.
Okay, so I cannot help you in this. I think you
No
can
problem.
mail to the NPTEL, so they can, I think,
Yeah,
help.
okay. Actually, I had already informed them that through Microsoft that link it's not working with me. Google Meet it's okay, but I checked with other Microsoft Teams it's okay. But through this environmental remediation, whatever the link I received every Friday, I'm trying to join, but I couldn't. So I already informed them, but there is no feedback from them or
Okay,
no
so just
reply
wait
from
for
them.
a few more days. Maybe they will reply you.
Yeah, okay.
Okay.
Okay, ma'am. Thank you.
Okay, thank you. Thank you so much. Okay,
Bye.
so I think we can end the session here. So,
Retention time, is there any formula for retention time you have? Actually, I did not go through. Actually, I'm working. That's just now I came from the office. So,
yes.
okay. No problem.
Yeah,
Now,
yeah.
is there any particular formula for retention value?
So, sir has derived the all the formulas which I am using. So for
Okay.
a PRB, we consider the flow as a flow reactor, and on the basis of mass balance, which is in I think lecture number 19. So he have derived
Nice.
these formula for retention time, and the formula based on the pseudo first order kinetics. We have derived a formula based on initial and final concentration of the pollutant. So you can go through the
Okay,
lecture
I'll.
slides. Uh, you will
Yeah.
get the idea for the formulas from where we are getting these formulas.
Yeah, okay. Now, regarding this week 2 and 3, I think actually that Bani sir, his lecture video had only like part of the lecture, and what you have addressed in the video, it's something more. So,
Like
so
week
I think
second,
week 2 and week 3, the same.
I think the content is same only. So you're talking about the questions or the content?
Not the question. Bani sir's video, what the lecture video we are receiving, this is less. And on the same week, what in the your YouTube, I saw there is something more explained. So this part is not covered in Bani sir's lecture video.
Which part?
Actually, that what is it is. Mm, okay, ma'am. I will discuss this next week. I'll note it down and I will discuss with you this next week.
So, okay, I think I need to recheck for the current
Yeah.
lectures which are being uploaded. So that can be a mistake
Yes.
from my
Yes.
end. So I will check
Yeah.
that.
Yes. Bani sir's lecture. It doesn't cover the full content of the
Professor
for
Valenki's
the week.
lectures you are telling about?
Yeah. Bani sir, what every week we are receiving one Bani sir's 30 minutes video. So it's not covering the
30
full
minutes.
content. What? Yeah.
So these are
Lecture
there are
video.
so there are five lectures now in for each week.
So maybe that we need to log in. Okay.
So you need to
Okay.
log into
Let
the
me try.
NPTEL portal, and from for each week, as far as I remember, for the last 4 weeks there are five lectures each week. So I'm going through all these lectures one by one.
Okay, I will try. I will check. I will check. Maybe it's something I missed it out or no. But whatever the link, it's being sent through that email or the announcement. That link, when we click, it's like only 30 minutes video, and the full what is the content for the whole week. It's not covered in that 30 minutes. So I
No,
don't
no,
know.
the
Don't know
lecture
if
we
there is any.
so each lecture is for 30 or 35 minutes. So there are around five lectures.
Okay.
So the lecture duration is around 2.5 to 3 hours.
Okay, let me check, madam. But I
You
did
log
not
into the
find that.
portal and then you have to check. Okay.
Yeah, with the portal only, and in the announcement there is like a email coming that the lecture videos for week 4 has been uploaded. The lectures can be accessed using the following week link, and with this we are not able to. This is
So on
covering
the
only a
left
30
hand
minutes
side, you
video.
will see the week 1, week 2, week 3, and week 4. So when you will go on that
Yes, yes.
tab and click, then you can see the lectures and assignments and everything.
Yeah, that video it's there itself. I see only 30 minutes. Can you just make a check, madam? Just I want to make
No,
sure if this is okay or not.
no, I have
Hmm.
also I have seen the lectures. So for each week there are five videos.
Each week there are 5 videos.
Yeah. So you please check with your by logging into your
1 minute.
portal.
Let me check. So each we need to click. Okay, okay. Now it's okay.
Okay.
Okay, ma'am. Now it's okay.
Okay.
Thank you, ma'am. Thank you for clearing.
Okay.
Thank you.
Okay. I think we can end the session here. So thank you so much for joining. Have a nice day.
Thank you, ma'am.
Okay, okay, I'm ending the session here. Thank you. Have a nice day.